So guys, in here we're going to learn the complete meta exploit from beginning to advanced. So in this meta exploit part, firstly we're going to understand the basic of meta exploit. After learning about the basics, we're going to go and then move through the meta exploit and then exploit the modules like auxiliary modules. And after that we're going to learn about the meta exploit payload encoder. Then we're going to learn the use case of gaining access to the system using metaexploit. So we're going to learn how to gain access using this metaexploit tool. Then after gaining access part, we're going to understand and learn about the maintaining access post, then exploitation. So we're going to maintain and access the post exploitation using the metaexploitable tool. Then after all of those basic part, we're going to use the advanced metaoperator for post exploitation. So after the post exploitation, we're going to learn about the Armitage, which is separate from this, and then we're going to use and move from basic to advanced uses of metaexploit. So now there will be some subsection in here, like into these basics of metaexploitable part, we're going to first learn about the different method of using metaexploitable framework. So after learning the framework of different method, we're going to then move to the components of metaexploitable framework. So into these basics of metaexploit, we're going to learn about these two parts. Then into these metaexploit and exploit module and auxiliary modules. So into this exploit module and auxiliary modules, there will be a two part 1 and part 2. Then after that, we're going to learn about the metaexploit payload encoder. So into this metaexploit payload encoder part, we're going to first learn about like how to work with metaexploit payload, how you can use this payload to work. Then we're going to learn about how to generate the complex payload from basic to complex. Then after learning about the generating and working with this payload encoder, then we're going to just work with these encoders. Sorry. Then after that, into this metaexploit payload encoder part, at the end we are going to learn about the hacking part, and we're going to learn how to hack using metaexploit payload encoder, and also we're going to demonstrate this part. Then we'll move to this gaining access to the system using metaexploit part. So into this part, we're going to first learn about the gaining access to the system using metaexploit payload. And then after that, after learning about the basics of gaining access, then we're going to move to the gaining access to system using metaexploit, which will be advanced. And then we're going to learn about the using advanced metaoperator for post exploitation. So into this part, we're going to first learn about the metaoperator networking. So then in the networking, this part we're going to learn about the railgun tool, which is a popular tool. So we're going to learn an use case of this railgun, and then also we're going to learn from basic to advanced of pivoting, which is an important part. So we're going to learn about this from basic to advanced, and also there will be some demonstration. And into this Armitage part, we're going to first learn how to scan with Armitage, how you can use first launch and then scan with Armitage. After that, we're going to launch the exploit against a target using the Armitage. And after exploiting, we're going to just use the post exploitation using this Armitage tool. And then we're going to move through the advanced uses of metaexploit. So into this part, we're going to first learn about the agenda and payload technique, then creating a payload with like tool like MSF Venom, and then pushing it to using the metaexploit. After that, we are going to learn the attacking SQL server using the metaexploit. Then token is stealing and impersonating the new account using the stolen tokens, which means that you can just impersonate a administration privilege using the token stealing part. And after that, we're going to learn about the pivoting and port forwarding part using the meta exploit, how we can pivot and port forward. And at the end of all of these meta exploitable lecture, we're going to learn and show you the real world example of meta exploit hacking and there will be a demonstration. So far in the server-side attacks, we have seen how we can use a default password or use a misconfigured service to gain access to the target computer. Today, we will be going through and have an example of a very simple thing, which is a vector. So, some program or services are shipped or come with some embedded vectors on them. So, we are going to exploit them, and I choose this very simple exploit because I want to introduce you to a framework called Metaexploit. So we're going to be using that framework a lot. So I wanted something simple to start with, then we're going to be go deeper with the framework. Now first let me show you how to find that exploit. So again, using the same method that we always been using, I have used nmap and I have to go for the 21 port. So we're going to using this framework, which is BSF FTP. So just search this, and as you can see, it has a Rapid7 website, and this is the exploit. So as you can see, the result comes, first result from the comes to the website called Rapid7. Now we have up to a Rapid7 company that makes this framework. So why I choose this particular exploit to show you today that. So we are going to exploit this service or this program or this problem using metaexploit. As you can see, Rapid7 is telling that this is the version of FTP that has a backdoor command execution, so it will allow us to basically execute commands on the target computer. So if it has this program installed and unlocked, so we can use this program which is installed and then you can execute commands on the target computer. So basically we want on the nmap we google the name services, and first thing that came up the service which is the backdoor command execution, because this is, as you can see, first result Rapid7. So it will be using this command execution. So let's just copy this backdoor which is this, and let's open our terminal and open MSF console. Okay, studying, so it will take up a couple of seconds. Okay, we are run. So just paste what you copy. As you can see, no use exploit, no payload is configured. So as you can see, we are now using this exploit. So just type show options to show all the options. As you can see, there is no rhost selected, only rport is selected, so we have to set our rhost. So the command you need to use to set rhost is just type set rhost. set our host and type the IP address of our meta exploitable machine 192.168. Okay, I mistakenly entered, so let's type again set our host 192.168.1.101. so let's type again to show the options to see if our host is selected or not. As you can see, our R host and also R port is now selected. So if we go to nmap, we can see that our port 21 is running on FTP. As you can see, FTP. So the client of our servers is running on our port 21. So this is, we don't need to change anything because we'll using port 21. So this is good. We need to change it to that. What we need to change is our R host that we changed. So just press enter after typing set R host and just you are just done. So what you have to do, just type exploit. As you can see, we are right now onto our meta exploitable machine. So we are right now on ID. So if I just type ID, as you can see, we are right now on our root access. If we just type ls, as you can see, these are all of the files that are on our meta exploitable machine, and we have access to our meta exploitable machine. And if we type pwd, as you can see, we are right now on root. So you can use any command that you can want in here in your target machine. So as you can see, this is very simple to use meta exploit, and in future we will be using more of our meta exploitable or MSF console, and we'll do the advanced stuff also. So far we have seen how we can use a service with the default password, or a service that has not been configured correctly, or a service that came with a backdoor to gain full access to the target computer. We also seen how to use the basic meta exploitable or meta exploit using the backdoor and install, or using a install on a FTP service in our previous lecture. So today we are going to have a more advanced look on meta exploit, and we'll see how to run a vulnerability that exists on a certain service. So it's a code execution vulnerability which will give us full access on the target computer as well as backdoor on the result also in here. So we have nmap also result also in here, and we're going to go those same things that we did in our previous lecture. So we will be using now, previously we used 21 port, now we'll be using 139, which is this Samba SMDB. So let's just copy this, search this on Google. So as you can see, if you search this on Google, this page will load up, which is the first page, and this is the vulnerability of this code. As you can see, Samba username map skip code execution. So just copy this, because this is the module that you need to use. So this is the main module. So just copy this and again same procedure as we did in our previous lecture, paste it in here. As you can see, we are now into this module, so we need to modify some of the things, because as we previously saw, our R host and R port is set, but we need to set R host. So just type set R host to our meta exploitable machine IP address, R host 192.168.1.101. So show options. As you can see, our R host is now selected. Also our R port is 139, because as you can see, we are now port on 139. So as you can see, there is another thing we need to set, which is the payload option. So what you need to do, you need to type set or show payloads. As you can see, these are all of the payloads that are available in here. So like in here, Ruby, Python, PHP, Netcat, which is a tool that will allow us connection between the computers. So this is the one that we need to use, which is this one. So I'm going to just type use and paste the payload that we copied. As you can see, you are now into this payload. So just type options. So as you can see, we need we did some mistake. We need to not use you need to type. So okay, we need to use it again. Sorry about that. So just first copy this, paste, then we need to set host 192.168.1.101 show options. As you can see, okay, I typed the wrong one again, so okay, no issue. Set R host. So R host will be the meta exploitable machine IP address, and L host will be the your Kali Linux machine IP address. So what's our Kali Linux machine IP address, which is 103, as you can see. So we have to just type 192.168.1.103. So let's check again. So okay, I think this is right now okay. We are using the user map script, as you can see. So we are using Kali Linux meta exploitable IP address, which is this one. Our port, which is 139, as you can see, 139. This is the Kali Linux machine IP address, and you can change L port also. This will not matter. You can use any L port you want. So just type now exploit R host 192.168. Oh, 1.101. Okay. Okay, set lots of mistakes. 192.168.1.101. Okay, so let's check again. As you can see, reverse netcat is selected, which is this one. As you can see, it's already selected in default, so you don't need to manually change. As you can see, this is the module, user map script, and this is the payload. So all is fine now. Let's type exploit. Okay, finally it's working. So as you can see, this command shell is now working, and it's connected to this IP address to this machine. So it has been changed this to it has been connected from this to this, as you can see. So let's just type ID. As you can see, we are right now on root. If you just pwd, also as you can see, so if you just uname -a, as you can see, you are right now on Linux meta exploitable server. So if you just also type ls, you will see all of the files that are on meta exploitable machine and so on. So you can use any Linux command you want. So that's the another exploit that you can use on your meta exploit. In this lecture, we're going to be talking about meta exploit, exploit modules, and auxiliary modules. So let's first talk about the exploit formulation. So exploit formulation is all about how exploits are made and what they are actually made of. So we will talk about various vulnerabilities and we will try to develop approaches and methods to exploit these vulnerabilities. In addition to that, our primary focus will be on building exploit modules for Metaxploit. We will also cover a wide variety of tools that will be aid for exploit writing in Metaxploit. However, an important aspect of exploit writing in the basic of assembly language. So if we do not cover the basic of assembly, we will not be able to understand how things actually work. Therefore, the first discussion about would be assembly language and the essential of required to write a exploits from it. So the element of assembly primer is that we will discuss a wide variety of registers supported in a different architecture. We will also discuss the extended instruction pointer, which is EIP, and extended stack pointer, which is ESP, and their importance in their writing out exploit. And we will also look at no operation, which is NOP, and jump, which is JMP instruction, and their importance in writing exploit for various software. So the basics. So basics is, let's talk about the basic. So let's talk about the basic that are necessary to learn about the exploit writing. So there I will be talking about the terms that are based upon the hardware, software and the security perspective in exploit development. So register is an area on the processor that is used to store information. In addition, every process that a processor executes is through the registers. x86 is a family of a system architecture that are found mostly on the Intel based system and generally 32-bit system, while x64 are the 64-bit operating system. Assembly language is a low-level programming language with simple operations. However, reading an assembly code and maintaining it is a tough nut to crack. A buffer is a fixed memory holder in a program and it generally stores data onto the stack or heap depending upon the type of the memory they hold. Debugger is a program that debugs another program at runtime to find the defined programs and defined problems, and a program that can face while executing various instructions and the stage of registry and memory. The widely used debugger are Immunity Debugger, GDB and only DBG. The shellcode that runs after the successful exploitation of the target is called shellcode. It defines the region of exploitation. This stack is act as a placeholder for data and generally uses the last in out, which is LIFO method to store the data, which means the last inserted data is the first one to be removed. Buffer overflow means that there is more data supplied in the buffer than its capacity. Format string bugs. So these bugs are related to the print statement in context with file or console, which given a variable set of data may disclose important information regarding the program. System calls are the calls to a system level method that invokes by a program under execution. So let's talk about the architecture now. So architecture defines how the various components of a system are organized. So let's understand the basic component first, and we will deep dive into the advanced stages. So before you start writing program and performing other tasks such as debugging, let's understand how the components are actually organized in the system with the help of this diagram. So we can clearly see that every main component in the system is connected using the system bus. Therefore, every communicating that takes place between the CPU, memory and I/O devices is via the system bus. CPU is the central processing unit in the system that indeed is the most vital component of the system. So let's see how things are organized in the CPU in this second diagram. So the preceding diagram shows that the basic structure of a CPU with components such as control unit, execution unit, register and flags. So let's talk about this. So the control unit is basically this is responsible for receiving and decoding the instruction and store the data into the memory. Execution unit basically means that this is a place where the actual execution takes place. So registers are placeholder memory variables that aids the execution. The flag is used to indicate events with some execution which is taking place. So let's talk about the registers. So registers are very fast component memory components. They are also listed on the top of the speed chart in the terms of memory hierarchy. Generally, we measure register by the number of bits that they can hold. For example, 8-bit register and the 32-bit register hold 8 bits and 32 bits memory respectively. General purpose segment, ELF, flags and index register are the different types of relevant register that we have in the system, and they are responsible for performing almost every function in the system, as they hold all the various of the POSIT. So let's talk about all the registers and their types. So first one is EAX. This is an accumulator that is used to store data and operands. So it is a 32-bit in size. EBX. This is a base register and a pointer to the data. It is a 32-bit also in size. ECX. This is a counter and it is used for looping purposes. It is also 32-bit in size. EDX. This is a data register and this stores the input or output pointer or IO pointer, and it is also a 32-bit in size. ESI or EDI. So there are index register that serves as a data pointer for memory operation. It is also 32-bit in size. ESP. So this is the stack pointer that register tells tell you exactly what is pointing in the stack currently, and it is a 32-bit file in size. EBP. So this is a stack data pointer and register. It is 32-bit in size. EAP. So this is a program counter and which is an instruction pointer, and it is also 32-bit in size, and most vital throughout in this lecture, it is also holds the address of the next instruction to be executed, and the SS, DS, ES, CS, FS and GS. So these are the segment registers. They are the 16-bit in size. So EIP or the program counter is a 32-bit register that holds the value in the next instruction the program will be executing. Now, why we are discussing it? We are discussing it because to exploit a system or service, we need otherwise the address that is currently residing in the EIP and with the address of the instruction where we want the program to be redirected. This means that when we exploit a system, we override the value of EIP, redirect the program flow to our required code and perform whatever function we need to perform on the target. So I created a C program using this. So the proceeding code then when executed by supplying a command line parameter will simply print out the value supplied. An important thing to analyze here is that a function name no work. Since it is not called anywhere in the program, it will not execute it. However, if we override the EIP with the address of this function, we can run this function by supplying a command line argument only. We can see the buffer size here is 10. Therefore, whatever we input after it, it directly overrides the address in the EIP. Therefore, it means that if we supply anything after the buffer, it becomes the content of the EIP register. However, let's see what the content will be that will override the EIP. So we need to override the EIP with the address of the function that we want to execute. Therefore, we need to find the address of the function. What we can do is by loading the proceeding of the program into GDB and searching for the start address of no work function. As in here, we can see that the module start with 0 into 0804 484 E0 address. Therefore, this is the address that we will be use and override the correct content of the EIP. So, and the next line, as we can see in here, we can see the proceeding result. We run the program under GDB and supplied the A character 14 times. We saw that whatever address that we supplied after the 14A, that characters became the content of EIP and execute the module. However, a catch is here that we applied this one, but the actual address was 0 into this one. However, if we can focus a bit, this is the same address but given in a reverse order. This is because when the value of the instruction are pushed into the stack and then they are popped, values are reversed. Hence, the address conversion into the current value is required. So, we can achieve this by putting 4 couples of 2 bytes, each in reverse order, so that when the popping of the value takes place, it comes to the actual value. We can also see when we run the program, it will be executed in the no work function, and we saw the following messages printed in the output like this is me. As you can see in here, this is me. In addition, we can clearly see how important the EIP registers are. Therefore, if an attacker overrides the value, they can redirect the program's execution. We can prevent this attack using proper and safer function in C. More information on function that we can avoid listed in like a website that I would suggest, which is security.web.cern.ch, and you can visit this website to get more information and the function. So at this point of time, most things may not be clear, but the idea here is just to show you that how to override the EIP address. So further we will talk about and see how to supply a 14A character instead of 10, which is actual buffer size. So let's talk about the gravity of ESP part. So ESP points to the shellcode. When it comes to the exploiting writing, everything we need to perform after a successful exploitation of the target depends on the shellcode of the payload. We have already seen how we can override the value of EIP. Similarly, whatever we supply after EIP goes to ESP. What is that mean is that after redirecting the program control, we supply the shellcode. When the shellcode executes, it performs the desired task on the victim. So as shown in this code here. So when we run the proceeding command, it will override the EIP. However, it will also put 500C character into ESP. Likewise, we need to insert the shellcode instead of the 500C characters. We will see in the later lectures how we can add shellcode to the various types of our exploits to achieve the desired functionality. NOPs or NOPs lead LED are no operation instruction that simply cite the program execution to the next memory address. We use NOPs to reach the desired place in the memory address or where we path may be irregular. We supply NOPs commonly before the start of the shellcode to remove the irregularities in the memory address without performing any operation and just sliding through the memory addresses. The /x90 instruction represents a NOP operation in the hexadecimal format. JMP instruction refer to the jump operation, that means to jump some line of the code that reaches the destination. While writing exploits, in order to execute the shellcode properly, we need to jump the program execution through another file or executable module. Only then we are able to make a successful jump. Before discussing how we can define variables on an assembly language, let's see how the things are organized in an assembly program, which is from high memory to low memory address. So let's analyze the diagram in here. So we can see in the diagram that we have a variety of sections that are organized in the preceding format. So let's understand what these various sections are and what their purposes is. So dot data, it initializes all data that resides in here. Dot BSS, all uninitialized data resides in here. Dot text, all program instructions are defined in here. Dot global underscore start, this is the external callable routine. Underscore start, this is the main function routine. Stack, this holds the variable and the data. Dot byte, which is 1 byte. Dot ASCII, which is a string. Dot ASCII, which is null terminated string. Dot initialize, which is 32-bit integer. Dot short, which is 16-bit integer. Dot float, which is single precision floating point. Dot double, which is double precision floating point. However, to declare these data types, we need to define it under the dot data section of the assembly program. Suppose we define a string variable called metaexploit with the hi how are you value. How can we can achieve this simply by writing a sum code, which is assembly language is just dot data metaexploit then ASCII hi how are you. So then how can you define the integer? You can define an integer by dot data a dot integer 10. Carrying enough knowledge of the basic assembly language, let's take a step further and build the simplest of the assembly program that will help us understand how things actually work in assembly. Our first example will demonstrate the simple printing of variable data onto the console. So which is first one is dot data, which initialize the data section. Hello, which declare the variable. Dot ASCII hello, which declare the data type of the variable. Dot text, which initialize the dot text section. Dot global underscore start, which define the global start. Underscore start, which define the start of the code. Move $4, %EAX. This load and write system call number to EAX, and this one load 1 into EBX to print onto the console. So this one load the actual variable into the ECX, then load the length of actual variable into the EDX, then this one is software interrupt. This one is load exit system call. This one is parameter to exit system call. The last one is load the software interrupt. So let's analyze the preceding in a simple program. So on the next line we define dot data to denote the start of the section for initialized data. Next we have declared a string called hello. Then we start with the dot text section, which define the global underscore text and define underscore start. So I defined all of this and how this works, and at the end we write integer $0 into 80, which to raise the software interrupt. So we again load a value into the EAX. However, this time the value loaded is 1, which denotes the exit system call. So we load the parameter 0 into the EBX to pass 0 into the exit system call. So this process is exactly like exit in C languages. So to run the program, so just type this simple command, which is like s code.s, then lda.out -o program, then /program, then it will print hello. So therefore we can see that it is easy to create a assembly program nevertheless. So I recommend you to look assembly in a little bit further, as it will help you to understand the exploitation of a software with much more ease. So what you can do is you can just go to a website which is like tutorialpoint.com _ assembly programming, then you will get more and more information about the assembly language with this website. So in this lecture we are going to be talking about how we work with our metaexploit payload. So what we will do is we will create a payload and a listener. So creating a payload and the listener vector is the most basic attack in advance in this attack vector. So we will generate a malicious executable payload that when made to run the target system, we will get the attacker completely access to the victim system. So let's proceed with the creation of the malicious payload. So from the main menu offset, we will select the fourth option, so which is create a payload and listener. So after this step, set will list different payload for the selection of the appropriate. Then we will select the appropriate one to use as shows in this screenshot. Selecting the second option, we will choose the payload type to be the Metapredator reverse TCP. We can choose the payload according to our requirement. This selected payload will spawn a shell at the target system and then send back the access to the attacker. However, let's see what the next option as follows. After selecting the appropriate payload, we will need to choose the encoding scheme for the payload to avoid the directions. We will choose the second option to denote the uses of the secreta underscore of GA underscore of NAI, which is very good. So let's see the next option. So after choosing the encoding schemes, let's define the port required to handle the incoming connections from the targeted system. In our case, we will be at the port number like 6666. However, in case of organization where restrictions are imposed on random ports, so we can go for ports such as 80 and 443, because generally they are not blocked. Therefore, as soon as we define the port, set begins the payload generating process and encode it with the selected encoding schemes. It also defines the location where the generated payload lies at the attacker system. Then we need to send this file to the victim using social media like emails or uploading at a server or any types of choices. So in this next step, set asks the following attacker to set up the handler. So if we choose yes, set launches and metaexploit with an exploit handler which will be waiting for incoming connections. So as soon as the victim runs the executable file, the payload will make a connection to the attacker system, giving the attacker complete access to the target system, as you can see in this picture. The set space exit on session command denotes returning from the exploit session or not returning from the exploit session. When a session gets created, moreover, the exploit -j command denotes running the exploit as a background process, and then this attack was the most basic attack vector of the set. And that's how you create a payload and a listener, and you can also approach to some of the advanced attack from previously. You can choose any handler as you want, and you can choose any exploitable vulnerability as you want. I am just done this create payload and listener for a testing purpose, and you can do any of the chosen one from here. I did the number 4. You can do like website attack vectors or spear phishing or wireless access point attack vectors, any of the point you want. So in this lecture, we're going to be talking about generating a complex payload. So the payload generator enables you to create a properly formatted executable that you can use to deliver shellcode to a target system without the use of an exploit. The payload generator provides a guide interface that walks you through the process of generating a dynamic payload or a classic payload. Depending on the types of payload that you choose to build, it will automatically display the applicable option that you can use to customize the payload. So before we perform an antivirus evaluation, let's look at how to create a standalone metaexploit binary payload with MSF payload. So for starters, we will create a simple reverse shell that connects back to the attacker and spawn a command shell. We will use MSF payload and Windows reverse shell TCP, but first let's look the available option for the shell reverse TCP payload using zero flag. So this is the available option. Now let's run MSF payload again and provide the option needed to create this payload in the Windows portable executable format or PE format. To do so, we provide the X option. So in here, this is the X option, as you can see, as our output format. So now we have a working executable, so we can start a listener with the multi-handler module. So this is the multi-handler module in MSF console, and multi-handler allows metaexploit to resend for reverse connection. So we first use multi-handler module in here, then quickly display the format option in here, show option. Then we set our payload to a Windows reverse shell at here. As you can see, we are using a reverse shell at here, so that it matches the behavior of the executable that created earlier. So to tell it the IP address, so we set the lhost at here, just typing set, we will set the lhost because lhost and lport wasn't set in default, so we have to set those manually. So then the port to listen on in is 31337, and then we are ready to go. As you can see, it is now open. Now we will use the popular AVG antivirus product in this following example because it can take some time and multiple tries to circumvent certain antivirus engines. Before we try to deploy a payload, we check the antivirus solution to make sure the payload get passed before we deploy it to the target. So in this case, when we test our payload with AVG, we see that it is detected, as you can see in here. One of the best ways to avoid being stopped by antivirus software is to encode our payload with MSF encode. So MSF encode is a useful tool that alters the code in an executable so that it looks different to antivirus software but will still run to the same way. Much as the binary attachment in email is encoded in base64, MSF encode encodes the original executable in a new library. Then when the executable is run, MSF encode decodes the original code into memory and then it executed it. So you can use MSF encode -H not L to list the MSF encode users option. Of the MSF encode option, the encoder format are among the most important. So for a list of encoder format, we use MSF encode -L as shown in here. So notice the difference of list in the encoder format and the encoder that are used for different platform, because for example a power PC, which is PPC, so encode will not, and PPC encode will not operate correctly on a x86 platform because of the difference of the two architecture. Now we will run a simple encode of MSF payload by importing a raw output from the MSF payload into MSF encode to see how the result affects our antivirus detection. So first we add the R flag in here, as you can see R flag, to the MSF payload command line to specify the raw output, because we will pipe it output directly to the MSF encode. So we specify the operating system like x86 in here and tell MSF encode to send executable out in put -t exe. Then it will go to this directory, and finally we run a quick check at here to ensure that the resulting file is in fact the Windows executable. As you can see, it is .exe. The response tell us that it will response will tell us that it is. Unfortunately, after the payload.exe, it is copied over the Windows operating system, and AVG detects our encoded payload, as you can see yet again. So when we are performing antivirus detection without modifying the static binary itself, it is always a cat and mouse game, because antivirus signatures are frequently updated to detect new and changed payload. As you can see, it instantly checked and got the result. So within the framework, we can get better result through multi-encoding, which allows the payload to be encoded several times to throw off antivirus program that checks for signatures. So in this example, as you can see, this one shikada ga nai, encoding the polymorphic, encoding is polyphonic. So this encoding is polymorphic, meaning that the payload will change each time the script is run. So of course the payload that an antivirus product will flag is a mystery. Every time you generate a payload, the same antivirus program can flag it out once and miss it another time. So it is recommended that you test your script using an evaluation version of the product to see if it bypasses the antivirus software prior to using it in a penetration testing. So here is an example of using a multiple encoder that passes. So here we use a Shikata Ganai feeding the code in a raw format, as you can see. So it goes into the 2 counts of alpha upper, this here, which then fed another 5 counts of Shikata Ganai, followed by a 5 counts of countdown, as you can see, and encoding at here, before finally directing the output at the desired executable format. So we are using a total 17 encoding loops in an attempt to circumvent the antivirus software, and as you can see, we have successfully shipped our payload from the antivirus engine. So ABG has not detected the multi-encode payload in here. So typically when MSF encode is run, the payload is embedded into a default executable template at like a directory called or directory called template, and the executable is template.exe. Although this template is changed on occasion, antivirus vendors still look for it when building signatures. However, MSF encode now supports the use of any Windows executable in the place of default executable template via the -x option. So in the following example, we encode our payload using a Process Explorer from Microsoft System Internal Suite as a custom executable template. So as you can see in here, download the Process Explorer from Microsoft, then we unzipped it in here, then we use the -x as I previously told to switch to specify the downloaded Process Explorer binary for use as our custom template. So after encoding is completed, we start up the multi-handler through MSF CLI, and then listen to the incoming connection, as you can see in here, and as you can see, after that command shell is open in here and this specific directory, and we have successfully opened a shell without being detected by antivirus software. As I was saying, that we start up the multi-handler through MSF CLI. So this one, to listen to the upcoming connection in here, as you can see. So, and as you can see, we have successfully opened a shell without being detected by any antivirus software like in here ABG. So the backdoor executable is not detected by the ABG. So in this lecture we will be talking about encoders and working with the encoders and like cautions with using the encoders. So let's talk about the detecting the metaexploit. So the detection of metaexploit payload isn't all that difficult. So if you are to create a payload with MSF Venom that we previously show you how can use that, you can get the same result every time. This allows you to write a simple rule to this particular payload and extract its configuration. Unfortunately, this is not the only way to generate a payload. Metaexploit has encoders which you can use to obfuscate your shellcode. They pack your payload into a self-decrypting blob of shellcode which becomes the original one when executed. These are slightly harder to detect as the x86 instructions are semi-randomized and the decryption key is chosen at random. One of the well-known encoder is Shikata Ganai, which uses a randomly generated key to XOR or XOR the instruction. The result is then used to alter the key, so it's a roaring XOR key. Detecting this encoder is not that hard. They all have a certain structure and certain CPU intrusion, which aren't obfuscated. This means that the encoder are also detectable by using some basic URL rules. The real challenge after that is to decoding the payload into a form that we can analyze further. So, to build a simple and custom emulator capable of running a x86 instruction, this way we will be able to detect an encoder and run that through the emulator. So once we detect it, then start executing memory. It has written that we can, and that we have decoded layer of the obfuscation, and in that case of Metaxploit, then another layer of obfuscation is coming up then looking at the Metaxploit payload. So let's talk about the x86 emulator. We have built a software implementation of the x86 instruction set, much like how a emulator works or old console or computers. The only thing standing out of the build that the x86 emulator to run on x86 hardware. The reason for that is for the security, and we have a potential malware that we want to analyze aesthetically, so having a control environment is a must. So we don't have any of this code to actually run on the processor outside our sandbox environment. The x86 instruction set has over 1500 instruction. It would be too much for an effort to implement all of those, especially when the encoders we try to emulate use a very small subset of those instructions. So after implementing the first version of our emulator, we start generating different encoders, and we kept adding instruction of the emulator until we go back to our expected payload. So let's give an example. If payload is encoded by a Shikata Ganai, then the running also we show you the basic and couple of example of Shikata Ganai in our previous lecture, so make sure you check that out. So Shikata Ganai first encodes, then automatically run in payload through our emulator. So then you can able to detect multiple layers of encoding, and for example like Shikata Ganai is a very popular one. So in terms of in our conclusion type, so we can say about these encoders, by understanding the way of Metaxploit encoder works, that we have been able to detect them and strip them to their encoding and previewing their configuration even if they weren't able to run in a dynamic environment or otherwise gave very little malicious indicator. So let's now talk about cautions while using encoders. So we should use encoders with care. An over-iterated payload might not work properly. It is advisable to encode the payload with a random number that iteration uses and test it against the proper working material. Then it take care and it taken when encoding payload is twofold, as like this, like it do not iterate over the payload. Never upload your malicious file on a virus testing sites. And on one important consideration that an encoder file must overcome are like the file is not included, which means that not loaded in our main memory, but it is scanned for infection. And the last one is the file is not explicitly scanned. However, it is executed and it gets loaded in the main memory, and the antivirus real-time protection flags marks it as a infected. Hello everyone, so in this lecture we will be talking about the hacking using metaexploit payload that use the encoders. So let's first talk about the exploring the Internet Explorer or explicit. So you know the basic of how heap spray work and how we can dynamically allocate memory and fill up the heap up with the NOPs and shellcode. Then we will be leveraging the exploited that uses this technique and something found in nearly every client-side exploit. The browser exploit of choice here is the Aurora exploit, and Aurora was most notoriously used in the attack against Google and more than 20 other large technology companies. Although this exploit was released in early 2010, it particularly resonated with us because it took down some major players in the technology industry. So we start by using the Aurora Metaexploit module and then set our payload. The following commands should be familiar because we have used them in our previous lectures, and we also see a couple of the new options that we will be discussing in this lecture. So first, notice that the default setting of the SRB host is 0000. This means that the web server is bound to the all interface, and the SRB port is 8080, which is the port to means which is the targeted user need to connect to the exploit to trigger. So we will be using port 80 instead of 8080. However, we could also set up the server for SSL, but for this example we will be sticking with the standard http dot URI path. So then we'll use this URL to user will, and that will need to enter the trigger for the vulnerability, and then we use this as a slash. So with our setting defined, and use your Windows XP virtual machine and connect to the attacker using the attacker IP address, and you will notice the machine become a bit sluggish. So after a little warning, you should see a Metapredator shell, and with this in the background the heap spray was performed and jump into the dynamic memory that was executed. So to hit your shellcode eventually that executed the dynamic memory. So if you open the task manager in your Windows and you run this exploit, you can actually see the memory of the IE explorer.exe growing significantly because of the contract growth on the heap. So you now have a Metapredator shell, but there is a slight problem. What if the targeted user closes the browser based on the sluggishness on her or on their computer? So you would effectively lose your session on the target, and although the exploit is successful, it would be cut off prematurely. Fortunately, there is a way around this, and simply just run migrate as soon as the connection is established and hope that you make it in time. The Metapredator skip automatically migrates to the memory space of a separate process, and usually it is to improve the chance of keeping your shell open. If the targeted user closes, then it originally exploited the process. Then just run migrate as I was saying. This is pretty much a manual process. You can automate this whole process using some advanced option to migrate to a process automatically upon a successful shell, and then just type show advance to list of the advanced feature of the Aurora module that you can find using this simple command. Just type show advanced. By setting these options, you can fine tune a lot of payload and exploit details. Now suppose you wanted to change the amount of tries on a reverse connection would do, the default is set to 5, but you might want to concern with the timeout and want to increase the connection retries. So we set it as 10. As you can see, connection retry set it as 10. So in this case, you want to migrate automatically and to a new process that in case the target user close the window browser right away. So under the auto run script migrate, simply just let Metasploit know that the auto run a script as soon as the Metasploit console is created. Using the migrate command with the -f, this one. So -f switches tells Metasploit to launch a new process automatically and then migrate to it. Now attempt to run the exploit and see what happens. Try closing the connection and see if your Metasploit session is still active. Since this is a browser-based exploit, you will most likely be running as a limited user account. Remember to issue the user privilege and get system command to attempt the privilege escalation on the target machine. And that's it. You just successfully executed your first client-side attack using a pretty famous exploit. Note that the new exploits are frequently being released, and so to be sure to search for all of those browser exploits and find which one is best suited for your needs and for your particular target. So let's now talk about file format exploit. So file format bugs are exploitable vulnerabilities found within a given application such as the Adobe PDF document. This class of exploit relies on a user actually opening a malicious file in a vulnerable application. And malicious file can be hosted remotely or sent via the email. So we briefly mentioned leveraging the file format bugs as a spear phishing attack in the beginning of this lecture. And in traditional file format exploit, you could leverage anything to which you think your target will be sustainable. This could be a Microsoft Word document, a PDF, an image, or anything else that might be applicable. So in this example, we will be leveraging a MS11 006 known as the Microsoft Windows create size dissection stack buffer overflow. So within Metasploit, perform a search for MS11_006, and our first step is to get into our exploit through MSF console and type just info to see what options are available. So in the next example, you can see that the file format is exported as here. This is the Windows 200, Windows XP and crash target, which is for debugging. So next you can see that we have a few targets that available to use, but we will make it automatic and leave everything to the default setting. So we will need to set a payload as usual. So in this case, we will select our first choice, a reverse Metasploit shell. So this one, we will set our first as reverse TCP because this is a reverse Metasploit shell, and then we set our L host to this machine IP address, set our L port, or mostly use this 443 because it couldn't detect, and then just you will use exploit. So as you can see, it will create a msf.doc file and generate the output file in this doc file, and our doc file is created. So what we will need to do is we will sending the payload. So our file was exported as msf.doc, as you can see, and it's sent to this directory within the Metasploit. As you can see, this is a directory. So now that we have our malicious document, we can craft up our email to our target and hope the user open it. So at this point, we should already have an idea of the target's patch level and vulnerabilities. So before we actually open the document, we need to set up a multi-handler listener. So this will ensure that when the exploit is triggered, the attacker machine can receive the connection back from the target machine, which is like reverse payload. So as you can see, we use this reverse TCP, we set L port and exploit the -J. So exploit running as a background, as you can see. So we open a document on a Windows XP virtual machine, and we should be presented in a shell, provided our virtual machine is Windows XP. So as you can see in here, we have successfully exploited a file format vulnerability by creating a malicious document through metaexploit and sending it to our targeted user. Looking back at this exploit, if we had performed proper reconnaissance in our target user, we could have crafted a pretty convincing email. And this exploit is one example of a number of file format exploit available in metaexploit. And you can check and try out the other metaexploit vulnerability. You don't need to try this one, you have others one, so you can that manually or other file formats that are available in metaexploit. So as a penetration tester, every bit of information can be used to craft an even better attack. So in this case, is the browser exploit and the file format exploit that are typically very effective and granted you a, and it will show very easy, and it will done in a couple of comments. As you can see, used in more than 4 or 5 comments to fully utilize this exploit. So that's all about the metaexploit payload encoders. Hello everyone, so in this lecture we are going to be talking about the basic of gaining access to the system using metaexploit. So gaining access is the most exciting phase. However, here the success result will vary depending upon the various previous phases. For example, whether we are able to clearly identify the critical areas and vulnerabilities in them or not. So let's talk about the system which we have tested previously. So here we are going to have many vulnerabilities, but still it is hard to find exploit to the port 80 based vulnerabilities, and it is a great deal of time which is required to create this exploit for them. So in this case, we will try to gain access with the exploit that we currently have. And as we seen previously, we have like port 445 that was found to be the vulnerable. Therefore, we need to try to fire up the good old metaexploit in metaexploit to exploit and try to gain access to the target. However, if we are not able to gain access with this one, we will try other vulnerabilities. The primary agenda of this phase is to exploit the maximum possible holes in the system and to gain the highest possible privileges. So let's just try to quickly exploit the target system. So we're gonna use this exploit to in this meta exploit. So what you have to do now, just as previously, as most of the cases, you have to set your host and payload. So how can you set? Just type set space rhost to this IP address that you want to exploit, and just payload, which is the meta exploiter reverse TCP. Just type this is the default vulnerable, and after that set lhost, and then simply just press exploit. So after setting all of those required option, we will continue to exploit the target and gain the meta operator access to it. So as you can see in here, we set the target as 3, and after targeting 3, then just simply just type exploit, and it will just start exploit in this selected host. So the first thing to do once we have gained access to the target system is to grant the highest possible privilege to our user. to do this, we will just jump the explorer.exe. As you can see, process by finding the process ID and using the migrate command in metaexploit to switch to it. Then we will elevate the privilege by using the get system command. So how we can achieve this? We can just simply achieve this. As you can see, we're gonna migrate this explorer.exe, so which is this port ID. So just type this one. So it will migrating from 1024 to this one. So after that, just type get UID, and which will get you the server username, which is this one, and then get system, which will got the system, which is technique one, and then again the get UID, and which will get you the authority or system. Then we'll first list the process running on the system using the ps command. Next, we will need to process the identities, which is PID. As I show you, this is the PID of explorer.exe process to migrate them from the exploit process into explorer.exe. So migrating from explorer.exe to this one. So as soon as we get the PID, we will migrate using the migrate command following by the PID of the process. However, after migration is complete, it is necessary to get the system level permission, as you can see in here, using the get system command. So let's now talk about covering tracks. So covering tracks may not be the necessary phase in carrying out a white box text. However, we should still know how to perform this for various scenarios that may arise. Suppose we have to edit a file on the target server, and then after editing the file, which may be crucial files such as configuration file or credential harvester file, we want to set the file's last modified time back to the actual modified time, which was before to our editing took place. So we can do this on the timestamp command in metaexploit. The entire idea is to evade the admin's eye by not making it obvious which files on his server on his personal computer were accessed and modifies. So after making a break into the system before reading a file, we need to check its creation date, so and last modified date and also last access time. So let's see how we can achieve this on timestamp. However, before we do that, let's see which file needs to be edited. So in this scenario, as you can see, we have a file name called creditcard.txt, and it's last modified on this date, and the time of the modification was this one, like 5 p.m. So as soon as we open this file, its access time is changed and it will be shown as this one. As you can see, access time will be changed. So let's just now modify the time to a time that is older than the actual access time, and also other times such as modified time and created time and entry modified. So we're gonna change all of those. So as soon as we run the, as you can see, we change all of those time using the timestamp creditcard.txt, and just set up the specific time using all of those modified access created and entry modified date and time using the simple command like this. So as soon as we run the timestamp command, it modifies the timing of our file to our given custom time, as you can see in here. Hence we are able to evade the admin's eye. The next thing is to remove the events log from the target system. So let's see where those are stored in your system. So as you can see in here, we have a plenty of logs in our event viewer under the computer management windows. So what you have to do, this is the computer management window, go to the event viewer, then just select the system, and after selecting the system you can see there is lot of logs in here. The post exploitation module name event manager will help us to delete all those logs, all these logs using the -c, which is this one -c followed by space nothing. So this will tell the module to clear all of those types of logs, as you can see in here. A application, clear application, you can just clear all of the security, clearing security, it cleared all of the security. As you can see, system, it cleared the system, and event log system, all of those logs will be cleared, as you can see. So after running this event manager command, you can see the logs managers is all empty and all logs are cleared. So we have successfully deleted all of those logs from the system, and those are some of the methods that will help you to evade system pursuit over the target system. However, for Linux based operating system, the logs resides on the logs directory under the var/var folder on the wwe folder on your Linux, Kali Linux machine or any Linux distributor. Hello everyone, so in this lecture we're going to be talking about gaining access to the system using Metaxploit payloads. So before you perform an antivirus evasion, let's look at how to create a standalone Metaxploit binary payload with MSF payload. So for starters, we will create a simple reverse shell that connects back to the attacker and spawn a command shell. We will use MSF payload and Windows reverse shell TCP, but first let's look the available option for the shell reverse TCP payload using zero flag. So this is the available option. Now let's run MSF payload again and provide the option needed to create this payload in the Windows portable executable format or PE format. To do so, we provide the X option. So in here, this is the X option, as you can see, as our output format. So now we have a working executable, so we can start a listener with the multi-handler module. So this is the multi-handler module in MSF console, and multi-handler allows Metaxploit to listen for reverse connection. So we first use multi-handler module in here, then quickly display the format option in here, show option. Then we set our payload to a Windows reverse shell at here. As you can see, we are using a reverse shell at here, so that it matches the behavior of the executable that created earlier. So to delete the IP address, so we set the lhost at here, just typing set. We will set the lhost because lhost and lport wasn't set in default, so we have to set those manually. So then the port to listen on in is 31337, and then we're ready to go. As you can see, it is now open. Now we will use the popular AVG antivirus product in this following example because it can take some time and multiple tries to circumvent certain antivirus engines. Before we try to deploy a payload, we check the antivirus solution to make sure the payload gets passed before we deploy it to the target. So in this case, when we test our payload with AVG, we see that it is detected, as you can see in here. One of the best ways to avoid being stopped by antivirus software is to encode our payload. with MSF encode. So MSF encode is a useful tool that alters the code in an executable so that it looks different to antivirus software but will still run to the same way. Much as the binary attachment in email is encoded in base 64, MSF encode encodes the original executable in a new library. Then when the executable is run, MSF encode decodes the original code into memory and then it executed it. So you can use MSF encode -H not L to list the MSF encode users option. Of the MSF encode option, the encoder format are among the most important. So for a list of encoder format, we use MSF encode -L as shown in here. So notice the difference of list in the encoder format and the encoder that are used for different platform, because for example a power PC, which is PPC, so encode will not, and PPC encode will not operate correctly on a x86 platform because of the difference of the two architecture. Now we will run a simple encode of MSF payload by importing a raw output from the MSF payload into MSF encode to see how the result affects our antivirus detection. So first we add the R flag in here, as you can see R flag, to the MSF payload command line to specify the raw output, because we will pipe it output directly to the MSF encode. So we specify the operating system like x86 in here and tell MSF encode to send executable out in put -t exe. Then it will go to this directory, and finally we run a quick check at here to ensure that the resulting file is in fact the Windows executable. As you can see, it is .exe. The response tell us that it will tell us that it is. Unfortunately, after the payload.exe, it is copied over the Windows operating system, and AVG detects our encoded payload, as you can see yet again. So when we are performing antivirus detection without modifying the static binary itself, it is always a cat and mouse game, because antivirus signatures are frequently updated to detect new and changed payload. As you can see, it instantly checked and got the result. So within the framework, we can get better result through multi-encoding, which allows the payload to be encoded several times to throw off antivirus program that checks for signatures. So in this example, as you can see, this one shikata ga nai, encoding the polymorphic, encoding is polyphonic. So this encoding is polymorphic, meaning that the payload will change each time the script is run. So of course the payload that an antivirus product will flag is a mystery. Every time you generate a payload, the same antivirus program can flag it out once and miss it another time. So it is recommended that you test your script using an evaluation version of the product to see if it bypasses the antivirus software prior to using it in a penetration testing. So here is an example of using a multiple encoder that passes. So here we use a Shikata Ganai feeding the code in a raw format, as you can see. So it goes into the 2 counts of alpha upper, this here, which then fed another 5 counts of Shikata Ganai, followed by a 5 counts of countdown, as you can see. encoding at here before finally directing the output at the desired executable format. So we are using a total 17 encoding loops in an attempt to circumvent the antivirus software, and as you can see, we have successfully shipped our payload from the antivirus engine. So ABG has not detected the multi-encode payload in here. So typically when MSF encode is run, the payload is embedded into a default executable template at like a directory called or directory called template, and the executable is template.exe. Although this template is changed on occasion, antivirus vendors still look for it when building signatures. However, MSF encode now supports the use of any Windows executable in the place of default executable template via the -x option. So in the following example, we encode our payload using a Process Explorer from Microsoft System Internal Suite as a custom executable template. So as you can see in here, download the Process Explorer from Microsoft, then we unzipped it in here, then we use the -x as I previously told to switch to specify the downloaded Process Explorer binary for use as our custom template. So after encoding is completed, we start up the multi-handler through MSF CLI, and then listen to the incoming connection as you can see in here, and as you can see after that command shell is open in here and this specific directory, and we have successfully opened a shell without being detected by antivirus software. As I was saying that we start up the multi-handler through MSF CLI. So this one to listen to the upcoming connection in here as you can see. So and as you can see, we have successfully opened a shell without being detected by any antivirus software like in here ABG. So the backdoor executable is not detected by the ABG. So launching a payload immediately. So for the most part, when a targeted user launches a backdoor executable such as the one that we just generated, nothing will appear to happen, and that can raise suspicious. To improve your chance of not tipping off a target, you can launch a payload while simultaneously continuing the normal execution of the launch application, as you can see here. So in this listening, we download the PuTTY, which is this one, Windows SSH client in here, and then access the PuTTY using the -k flag in here, and the -k flag configures the payload to launch in a separate thread from the main executable so that the application will behave normally while the payload is being executed. Now as shown in here, when the executable is processed with AVG, it comes back clean and should execute while still presenting us with the shell. So when choosing a embedded payload in an executable, you should consider using GUI based application. So if you are not specifying the -k flag, if you embedded a payload into a console based application, then when a payload is run, it will display a console windows that won't close until you're finished using the payload. So if you choose a GUI based application, then do not specify the -k flag. So when the payload is executed, the target will not see a console window and they will not pay attention to these little details that can help you remain steady during the engagement. So as you can see in here, AVG declares the payload is safe and the computer is secure. Packers are tools that compress an executable and combine it with the decompression code. When this new executable is run, the decompression code recreates the original executable from the compressed code before executing it. This usually happens when transparently, so the compressed executable can be used in exactly the same way as the original. The result of packaging a process in a smaller executable that retains all the functionality of the original. As with MSF encode, the packers change the structure of an executable. So, however, unlike the MSF encode, the encoding process, which often increases the size of executable, a carefully chosen packer will use a various algorithm to both compress and encrypt the executable. So next, we use the popular UPX packer with backtrack to compress and encode our payload 3.exe payload in an attempt to evade antivirus software detection. So as we install the UPX and then we run the UPX with no argument to view if it's command line option, then we use the -5 option to compress and pack our executable. Then we see that the UPX compressed the payload, which is 59.46%. So in our test, only 9 of 42 antivirus vendor detect the UPX packed binaries. So that's how you use gain access to the system using metaexploit payload without getting recognized by any antivirus. In this lecture, I am going to talk about gaining access to the system using metasploit metapredator. So at first, let's briefly talk about what is metapredator. So metapredator is one of the flagship product in Metasploit and is leveraged a payload after a vulnerability is exploited. A payload is the information returned to us when we trigger an exploit. For example, when we exploit a weakness in a remote procedure call, which is RPC, trigger the exploit and then select the metapredator as the payload, we would be given a metapredator shell to the system. Metapredator is an extension to the Metasploit framework that allow us to leverage Metasploit functionality and further compromise the target. Some of this functionality includes way to cover your track, reside purely in memory, dump hashes, access operating system, pivot, and much more. So, before we dive into the specifics of metapredator, we first need to compromise the system and get a metapredator shell. We begin by identifying the service and ports running on the target by conducting a port scan with nmap to find a port to explain. So as you can see in this picture, after conducting our port in here, we see that some interesting parts are accessible, including MySQL. As you can see in here, MySQL and -s, a potential attack vector. But perhaps the more interesting thing that nmap tells us that this machine is running Windows XP Service Pack 2, as you can see in here, Windows XP Professional Service Pack 2, which is now the end of a life, which means some published vulnerabilities will not have been fixed and patched by the installation of Service Pack 3. Also note that we see some standard FTP on here, Microsoft FTP and SMTP in here, as you can see SMTP in port, so which might be available to be leveraged for an attack, but we can see on port 80 is open. As you can see, port 80 open HTTP, which means that we have a potential web application to attack. So in this example, we will attack port 1433 MySQL because this is often an entry point of weakness that can lead to a complete compromise and full administrator level control over the target. To begin, we identify the MySQL installation and then launch a MySQL server brute force attack to see if we can guess a password. By default, MySQL is installed on TCP port 1433 and UDP port 1434. Though newer versions allow for installation on a dynamically allocated port which can be randomized, luckily port 1434 UDP remains the same and we can query it by identifying the dynamic port on SQL server. Here we scan the system and see that MySQL port 1434 UDP is open, as you can see in here. As you can see, we scan our host and see that my MS SQL UDP port 1434 is open. When targeting MS SQL, we can leverage the MS SQL underscore ping module to brute force the MS SQL port and attempt to guess the username and password. When MS SQL is first installed, the program will require the user to create an which is an SA, which is our system administrator account. You will often be able to guess or brute force the system administrator account password because when administrator install this application, they do not understand the security ramification of using either a blank password or something too simple. So in this next example, we look for MSSQL underscore ping module and attempt to brute force the SA account, which is system administrator account. So after calling the MSSQL underscore ping module, which uses this and setting our option, we see that SQL service installation is found at this IP, which is this one. As you can see, 192.168.33.130, this IP. The name of the server is, as you can see, this one, and its version is as you can see, this one, 9 point something. That equals to SQL Server 2005 Express, and we know that it's listening on TCP port 1433, as you can see, this one. So next we brute force the server with a frameworks MSSQL underscore login module. So we start the MSSQL login module at this and point it to the default password word list from fast track at this one. This is the word list that we will select all, guess the password, because we discussed as you know what fast track. So in here we have successfully guessed the SA password, system administrator password, using this word list file that we saved in this directory, because then what it is we set the host as previous host, as you can see, this one, and we thread at 10 and with barbers that we set it at false. So now we have a question like, what is fast track? So fast track is a tool created by one of the authors that leverage multiple attack, exploit and meta-exploit framework for payload delivery. So one of the fast track feature is to ability to use brute force attack and compromise MySQL automatically. As you can see, this is pretty simple. Just set rhost, set thread, select your destination word list file, then type exploit and then let's run. By running MS SQL from a system administrator account, we can execute the stored procedure xp underscore cmp as shell. Basically it will be cmd shell, sorry, my mistake. Which lets us interact with the underlying operating system and execute command. The xpcmd shell is a built-in store procedure that ships by default with all SQL server. You can call this store procedure and have it query and execute underlying operating system that calls directly with MS SQL. Think of it as a kind of super user command prompt that allow you to run anything you want in operating system. When we gain access to system administrator account, we find that the MS SQL server is generally running with system level permission, which allow us the full access as an administrator to both MS SQL and the machine itself. To get a payload onto the system, we will interact with this xp underscore cmd shell, add a local administrator and deliver the payload through an executable. So as you can see all of it in here. After selecting the MSS SQL, the setting our payload to Metapreter, then all we need to do is set the standard option before starting our Metapreter session. So we have succeed in opening a Metapreter session at here. As you can see, Metapreter session is open at a target machine. So to recap, in this attack that described here, that we use the MSS QL underscore ping module to guess the MS SQL system administrator password, which we discovered is password 123, as you can see in here. We then leverage the MS SQL payload to communicate with MS SQL and upload a Metapreter shell through the MS SQL and the other shell that was represented to us, thereby completely compromising the system. So once the Metapreter shell is presented, we know that the exploit was successful and we can continue with post exploitation on the system. So let's talk about some basic Metapreter command. So having successfully compromised the target and gained a Metapreter console on the system, we can get or gain more information from this Metapreter command. So use the help command at any point will give you more information how to use Metapreter. So the first one is capturing a screenshot. Metapreter screenshot command will export an image to the active user desktop and save it to this directory. So desktop screenshot offer a great way to learn about a target system. For example, like you can see which software is installed on the machine or etc., something like that, which means that we will need to be cautious with what we upload on the system, because if they have any antivirus system or antivirus software is installed, then we won't be able to exploit the machine. So it's a must for making a screenshot on the desktop. Second one is system info. So another command we can specify is system info, sysinfo or sysinfo, which will tell us the platform their system is running. So as you can see, if you use the sysinfo, the system is running on XP Service Pack 2 because Service Pack 2 is the end of life, and we can assume that we can find a ton of holes in this system because Windows is now running Windows 11. So Windows stopped giving security patches on previous, like even on Windows 7 So all those are vulnerable. So you can just take attack from this Windows machine. Capturing keystrokes. Now we will grab the password hash value from the system, which can either be cracked or used in an attack. We will also start keystroke login, which means recording a keystrokes on the remote system. But first, let's reach the running process on the system with a ps command. So just type metapletter in and then just type a ps and it will give you all those ps command. So executing ps at 1 provide a list of running processes including, as you can see, exexplorer.exe, and we issue a migrate command to move our session into explorer.exe. So process space, once the move is complete, we can start the keylog underscore regular module, which is this one, and stopping it after some time. You can stop it by using Ctrl C or Command C on Mac. And finally, in here, as you can see, in another terminal window, we dump the content of the keystroke logger to see what we have just caught, which is the administrator password. As you can see in here, we got the administrator password. In this lecture, we are going to be talking about gaining access to the system using Metasploit in advanced way. So let's first talk about pre-engagement interactions. Planning is the first step in pre-engagement. During a true planning phase, we would identify our targets and our primary method of planned attack, which might include social engineering, wireless, internet, or internal attack vectors. Unlike an actual penetration test, here we will not be targeting a specific organization or a group of systems. We will perform a simulation using our known virtual machines. So for purposes of our simulation, our target will be protected by meta-exploitable virtual machine as IP address. The meta-exploitable target is a machine attached to an internal network protected by a firewall and not directly connected to the internet. Our Windows XP machine is behind the firewall with only port 80 open and IP address will be 172.168.172.16.32.131. The next step is intelligence gathering, which is one of the most important phase in the process, because if you miss something here, you might miss an entire avenue of attack. Our goal at the point is to understand what we are going to attack and determine how we might gain the access of the system. We begin with a basic nmap scan with against our Windows XP virtual machine, and we find that port 80 is open. As you can see, port 80 is open, and we use nmap's stealth TCP scan, which is typically effective in detecting ports without triggering defenses. Most IPs can detect port scans, but because port scans are so common, they are generally considered regular noise and that are ignored as long as they are not aggressive. We discovered what happened to be a web server running on this server. This is typically when attacking internet-facing system, most of which will limit the port accessible by internet users. So in this example, we find that port 80, the standard HTTP port listening. So if we browse to it, we can see something similar to this web application that was identified. Having identified port 80 as open, we could enumerate any available edition system, but we are interested only in the single target. So let's move on the thread modeling and attempt to identify the best route in this system. The web page that we found gives us a chance to enter input in user and password field. So at this point, you as a penetration tester should think about the side of the box and try to determine what the best avenue is going to be. When you are performing applications or security penetration test, consider using tools other than Metasploit such as Burp Suite, and when appropriate, don't feel locked into a single tools. In the following example, we will attempt to manual attack by entering test into a user field and in a single quote in the password field. Prior to the submit of the form, our username and password should be look like this. As you can see, test and the one password, which is attempting to leverage the SQL injection. Take a moment to consider what is occurring on the backend when the server reacts the input. Here we simply try to start a new SQL statement and appended our some bogus data on it. You probably won't find any web application in the world that are as easy to attack as this one, but this makes for a good example. And it was not too long ago that this sort of error were in fact being discovered all the time. When we click the submit button, we got will be error message in here. So the error message indicate that SQL injection flaw is present based on the SQL exception, and the error syntax near. As you can see, this one error syntax near message shows that the test input caused it. With a quick Google search, we can determine the backend database is Microsoft SQL, and purely based on the error messages that were presented. We won't go how to perform SQL injection on web application here, but you can easily manipulate the input parameters to attack a given system and completely compromise it. Notice that we still haven't actually attacked system yet. We have simply tried to identify a viable attack vectors in the system. Now that we know how we can potentially compromise the system, it's time to move on to the exploitation phase. When we look for vulnerabilities in the web application, we found a viable attack vector via a SQL injection. In this instance, FastTrack is our best option for compromising the MS SQL server and getting access to our target through Metapredator. Because previously we described how it attacks Microsoft on SQL based injection vulnerability with ease. So after we have a Metapredator console, we will look at how to gain access a Metapredator system on the internal network. We will use SQL Punch or SQL PW which is to deploy the Metapredator console via SQL injection on the target to gain administrator access to its not front end, it will be on back end database. Recall from our previous lecture that SQL Punch is an automated way of attacking MS SQL based injection flaws, and it uses multiple methods of target in an attempt to fully compromise the SQL server via the XP_CMD shell, which we previously talked about, that start the procedure. Before launching that attack, we need to set up some through MSF console. For practices, let's create our own Metasploit listener manually. So FastTrack can set it up for you. We will be adding a So we will be adding this load auto add root function within the meta exploit, so that we can automatically connect to system on the internal network, and then we will create a listener and launch fast track to attack this system. So with our listener waiting for a connection from our soon to be compromised target in here, we launch fast track. Then this should look familiar because we have essentially attacked the web application through fast track and exploited it via the SQL injection attack. We use the XP_CMD shell, which we previously also did how it is worked in here. Then that stored the procedure and the binary to hex conversion technique to present the fully fledged metapreter shell. So at this point we should have a metapreter console running at the background within MSF console, so we can begin to scan the target subnet for other live systems. To do this, we will upload nmap to the target and run it from the Windows machine. First, download the nmap from a simple Google search will get you the download page of nmap, or otherwise insecure.org.in is an executable format that saved it locally. Then we will be uploading this to our target. So next we will connect to the target via the RDP, which is a Microsoft Remote Desktop Protocol, a built-in graphical remote administration protocol that lets you interact with the Windows desktop as you are sitting in front of the remote machine. So after we are connected with our metapreter session, we will use the get GUI metapreter script to, as you can see, this is running a get GUI metapreter script to tunnel the RDP back out to us and over the port of 8080 somewhere. So this command line, so we can log into the system with a newly created user account, and we then use the metapreter to upload nmap to the target. So our goal is to install nmap on the compromised Windows target and use the system as a staging ground for the further attack. So conversely, you could use TCP port scan to directly through the metasploit, but the choice is a matter of personal preference and the method. So as you can see, first we run the get GUI and then we create a shell. So after that we uses the MSF metasploit to add. Then after that the command, as you can see, the metasploit had been added. So after that what it did is we select the local group as administrator support. So for this we added msf/add. So this command also be added. So what you have to do now is just upload those nmap.exe, then it will be uploaded, and we have our launching pad for additional attack. As you can see, with nmap installed on the target, we are essentially sitting on the internal network. We can now attempt to enumerate internally connected system and then further penetrate the network. With our metapreter session granting us access to the internal network via the load auto_add, then command, then we can scan and exploit the inside host using the compromised Windows XP target as the launching point, and we are effectively connected to the internal network, so we should be able to reach our metasploit system. So let's begin with the port, with a basic port scan. So as you can see, very easy. As you can just type nmap.exe, then select your IP address and the port. As you can see, most of the port are open. As you can see, all the port are open. Couple of them are from HTTP, couple of them from SSH and telnet, as you can see. And also you can see which is the which. This is the open SSH. So after that, there is also here. So you can also see the information of this service info. As you can see, this is the Unix or Linux operating system. So here we see a series of open ports based on the Nmap's OS detection. We can see the scan system is an Unix or Linux variant of some sort of. Some of these ports should jump out at you, such as FTP, Telnet, HTTP, SSH, Samba, MySQL, PostgreSQL and Apache. So all of those are performed in here. Then identifying a vulnerable service, because a few port that looks interesting will start banner grabbing each one to find a way to get into the system. So exiting the system, we know that Pro FTBD 1.31 is running on port 21. As you can see in here, port running 1.3 port 21. As you can see, port 21. Next, we use SSH to learn more about the target. The next listing tells us that our target is running an older version of OpenSSH. As you can see, older version, and especially which is written in Ubuntu. Now we issue the following to determine the version of Ubuntu running on this system. So we set the rhost as this IP. Then as you can see, the rhost is this set. Then just run. As you can see the Ubuntu version in here. Then again use the set to set the IP of this SMTP version. So after that, just run this, and great. We know the system is running a Ubuntu 8.04 and that two unencrypted protocols, which is Telnet and FTP. So with those two might be used to come into play later. So let's look into SMTP to see which version of our target is running. So remember that we are trying to identify the running version of the service operating on the various remote systems. So as you can see in here, the postfix mail server appears to be running. And this is running on the Metaexploit server. This process is continued through all the defined ports that have been discovered as listening in listening on our target. The various auxiliary modules are very useful for this work. So when you are finished, you should have a list of the version of software running on the system and information that you will use when you targeting an attacks, and that's all. In this lecture, we're going to be talking about maintaining access to the system and post exploitation. So first of all, let's talk about using persistence. So Metasploiter persistent script allows you to inject a Metasploiter agent to ensure that Metasploiter is running even after the target system reboot. If this is a reverse connection, you can set it the intervals for the target to connect back to the another machine. So if it's bind, and if you have an attempt to bind an interface at it again, and there will be a given time. So there is a warning. So if you use this functionality, be sure that you remove it after you are done. So if you forget to do this, any attacker can also gain access to the system without authentication. So in this, as you can see in this here, we run persistence and tell Windows to auto start the agent at a boot time which is -x, and wait 50 seconds, which is I 50. Before connection, retrieves, run the port on 443 and connect IP, which is this IP. So we then established a listener for the agent at the point 1, as you can see in here, and with use multi/handler. And after seeing it a couple of options and running exploit in this here, connection comes, as you can see, is as expected. So as of this, the only way to remove the Metapredator agent is to delete the registry entry in the HKMM, this folder, this folder, and then remove the BB escape located in temp folder, which is this folder. So make sure to document the registry key and location, which is this location, to remove them manually. So generally you can do this through Metapredator or drop to a shell and remove it that way. So if you feel more comfortable using a GUI, then you can use run BNC and remove the escape with regedit. So note that the registry key will change each time, so make sure you document where Metasploit adds the registry key. As mentioned earlier, the Metascape scripts are slowly being converted to post-exploitation module. The move to post-exploitation module will finally give you a full consistent inductor and format to the Metasploit module. So as we previously talked about, you will see the overall structure of auxiliary modules and exploit. So in the past Metapredator script, they used their own format, which was very different from the way the other module behaved. One added benefit of moving the modules to the same format is the ability to perform the same attack on all sessions available. Suppose, for example, that you have like 10 open Metapredator shell. In the traditional fashion, you would need to run #dump on each or write custom script to query through each console. So in this new format, we would be able to interact with each session and perform the #dump on multiple systems if needed. So as you can see in here, we have a list of a post exploitation module. So enter the following and then press the tab key on your keyboard. We will enter this following run post line, and then you're done. One of the newest or newer feature in the Metasploit framework is the ability to upgrade a command shell payload to a Metapredator payload once the system has been exploited by issuing the -u command. This is useful if you have a command shell payload of a integer stager and then find that this newly exploited system would make the perfect launching pad for further attacks into the network. So let's look at a quick example from start to finish using MS-08067 with a reverse command shell as a payload and upgrade it to a Metapredator shell. So in here, as you can see, we issue the setg command for lhost and lport, which is required for order for the session -u to upgrade the metapletter at here. Which is the setg command sets the lport and lhost globally in Metasploit, not just for this exploit. So notice in here, when we exploit the system, when we issue the exploit-z command, which will not interact with the session once the target has been exploited. So if you had already exploited or executed the exploit command, at this time you could simply press just Ctrl+Z and just run the session in the background. You can interface with any Windows native API directly through a Metasploit add-on called Railgun, which was written by I think Patrick HB. By adding Railgun to the Metasploit framework, you can natively call Windows APIs through Metapletter, all through the Windows API. For example, in the following listing or following you will drop a interactive Ruby shell available through Metapletter. The IRB shell which is Ruby shell, allow us to interact directly with Metapletter through Ruby based syntax. We will call Railgun in the example and create a single pop-up box saying hello world. So on our target Windows XP machine, you should be see a little pop-up box with world in the title bar and hello in the message box. So in this example, we simply call the user32.dll and the message box a function, which takes the parameter as you can see in here. So note that for a list of all documented API calls, you can visit msdn.microsoft.com for get more information about that. So now back to the code. So we won't cover Railgun in details. You can find tutorials with the framework directory under like source Metapletter and under the server, which is Railgun, but this gives you an idea of its power. So the implications are huge. Railgun gives you the same capabilities as the native Win32 application with full access to the Windows API. Now we will be setting up a persistent access. So after gaining access to the target system, it is mandatory to retain that access forever. Metapletter permits us to install backdoor on the target using two different approaches. First one is mat-sbc and second one is persistence. Persistence is now new to us and we discussed in our previous lecture while maintaining access to the target system. So let's see how mat-sbc works. So the mat-sbc service is installed in the compromised system as a service. Moreover, it opens a port permanently for the attacker to connect whatever or whenever he wants. Installing a mat-sbc at the target is easy. As you can see, we can use the mat-sbc service to create a service at port 31337 and upload the malicious file as well. So later, whenever access is required to this service, we need to use mat-sbc_bind_tcp payload with a exploit handler script, which will allow us to connect to the service again, as you can see in here. The effect of mat-sbc remains even after a reboot of the target machine. This is handy when you need permanent access of the target system, as it also saves time that is needed for re-exploitation. We just saw how we could perform advanced tasks with Metapletter. This indeed makes the life easier for penetration tester, and it makes much more easier. Now let's deep dive into the working of a Metapreter and uncover the basic building process of Metapreter module and script. This is because sometimes it might happen that Metapreter alone is not good enough to perform all the required tasks. So in this case, we need to build our own custom Metapreter module and that can perform or automate various tasks required at the time of the exploitation. So let's first understand the basic of Metapreter scripting. The base for coding with Metapreter is the application programming interface, in short, which is we call API, which is calls and API calls and mixin. These are the required to perform a specific task using the specific Windows level dynamic link library, which is DLL, and some common tasks using a variety of built-in Ruby based module. Mixing are Ruby programming based classes that contains method from various other classes. Mixing are extremely helpful when we perform a variety task at the target system. In addition to this, mixing are not exactly a part of IRB, which means Ruby, but they can be very helpful to write specific and advanced Metapreter script with each. So API calls are Windows specific calls that used to call out a specific function from a Windows DLL file. We will learn more about API shortly in our later lectures. Let's work out with a simple example that Metapreter script, which will check whether we are the admin user, whether we have a system level access, and whether the UAC is enabled or not. The script starts by calling the is_admin method from the lib/msf/core/post with prb prev.rb file and storing the boolean result in a variable named isAdd. Next, we simply check whether the value isAdd variable is true or not. However, if it is true, it prints out a statement indicating that the current user is the admin. Next, we perform the same for the is_system and enabled method, a UAC_enable method from the same file in our script. So this one is the simplest script. The script will perform as its function name suggests. However, a question that arises here is lib_msf_script_metapreter contains only 5 files with no function defined in them. So from where did Metapreter executed this function? From where? So however, we can see that the 5 file is shown in this first picture. As you can see, 1, 2, 3, 4, 5 files. When we open those 5 files, we will find that this script had included all the necessary library files from a variety of sources within Metasploit. Therefore, we do not need any additional include of this function library that was into it. After analyzing the metapreter.ruby file, this one, we find that it includes all those 5 files as seen in the picture. So these 5 files further includes all the required files from various places in Metasploit. So if you save this code into my script1 directory and launch the script from Metapreter, this gives you a similar output like this. So we can clearly see how easy it was to create a Metapreter script and perform a variety of tasks and the task back automation as well. So I recommend you to examine all the included files within this 5 files that we discussed in our lecture. Railgun sounds like a gun set on rails. However, this is not the case. It is much more powerful than that. Railgun allows you to make calls to a Windows API without the need of you to compile your own DLL. It supports numerous Windows DLL files and is the way for us to perform system level tasks on the victim machine. So let's see how we can perform various tasks using Railgun and perform some advanced post exploitation with it. Railgun requires the IRB shell to be loaded into the metaperator. So as you can see in here, we can jump to the IRB shell from metaperator. We can see the preceding picture that simply typing in IRB from metaperator drops us to the Ruby shell or Ruby interactive shell. We can perform a variety of tasks with the Ruby shell and then can execute any Linux command from here. Railgun gives us immense power to perform tasks that Metaexploit cannot perform. We can raise exception to any DLL file from the bridge system and create some more advanced post exploitation mechanism. Now let's see how we can call a function using basic API calls Railgun and understand how it works. So this is the basic structure of a API call in Railgun. The client underscore Railgun keyword defines that we need to you need the functionality of a Railgun for the client. The DLL name keyword specifies the name of the DLL file for making a call. The function keyword is the syntax specifies the actual API function that is to be provoked with request parameter from the DLL file. So this is the example, and from this the result of this API will be like this. Here a call is made to the lock workstation function from the user 32 DLL that result in a locking the compromised system. As you can see, the system is in lock. So next let's see an API call with parameter. So this is the API. So when this command runs, it deletes a particular username from the client machine. So if you just try to delete the SSS username, as you can see in here, the user seems to have gone missing, or as you can see previously it was in here but now it's not now. So Railgun is really an awesome tool and it has removed the user's SSS successfully. Before proceeding further, let's get to know what the value nil is in the parameter was. The nil value from this here, the nil value defined that the user is in local network. However, if the system had been in remote one, we would have passed the system net -BIOS name in the parameter. DLL files are responsible for carrying out the majority of tasks. Therefore, it is important to understand which DLL file contains which method. Simple alert box are generated too by calling the appropriate method from the correct DLL file. It is very similar to the library file of Metaexploit, which have various methods in them. So I recommend you to study a variety of API calls before proceeding further with creating a Railgun script, and this will help you to get more information and it will help you to work fluently. Now we will be setting up a persistent access. So after gaining access to the target system, it is mandatory to retain that access forever. Metapreter permits us to install backdoor on the target using two different approaches. First one is mat SBC and second one is persistence. Persistence is now new to us and we discussed in our previous lecture while maintaining access to the target system. So let's see how mat SBC works. So the mat SBC service is installed in the compromised system as a service. Moreover, it opens a port permanently for the attacker to connect whatever or whenever he wants. Installing a mat SBC at the target is easy. As you can see, we can use the mat SBC service to create a service at port 31337 and upload the malicious file as well. So later, whenever access is required to this service, we need to use mat SBC_bind_TCP payload with a exploit handler script, which will allow us to connect to the service again, as you can see in here. The effect of mat SBC remains even after a reboot of the target machine. This is handy when we need permanent access of the target system, as it also saves time that is needed for re-exploitation. We just saw how we could perform advanced tasks with Metapreter. This indeed makes the life easier for penetration tester, and it makes much more easier. Now let's deep dive into the working of a Metapreter and uncover the basic building process of Metapreter module and script. This is because sometimes it might happen that Metapreter alone is not good enough to perform all the required tasks. So in this case, we need to build our own custom Metapreter module and that can perform or automate various tasks required at the time of the exploitation. So let's first understand the basic of Metapreter scripting. The base for coding with Metapreter is the application programming interface, in short, which is we call API, which is calls and API calls and mixin. These are the required to perform a specific task using the specific Windows level dynamic link library, which is DLL, and some common task using a variety of built-in Ruby based module. Mixing are Ruby programming based classes that contains method from various other classes. Mixing are extremely helpful when we perform a variety task at the target system. In addition to this, mixing are not exactly a part of IRB, which means Ruby, but they can be very helpful to write specific and advanced Metapreter script with each. So API calls are Windows specific calls that used to call out a specific function from a Windows DLL file. We will learn more about API shortly in our later lectures. Let's work out with a simple example that Metapreter script, which will check whether we are the admin user, whether we have a system level access, and whether the UAC is enabled or not. The script starts by calling the is_admin method from the lib/msf/core/post with prev.rb file and storing the boolean result in a variable named isadd. Next, we simply check whether the value isadd variable is true or not. However, if it is true, it prints out a statement indicating that the current user is the admin. Next, we perform the same for the is_system and enabled method, UAC_enable method from the same file in our script. So this one is the simplest script. The script will perform as its function name suggests. However, A question that arises here is lib underscore msf underscore script underscore metapreter contains only 5 files with no function defined in them. So from where did metapreter executed this function? From where? So however, we can see that the 5 file is shown in this first picture. As you can see, 1 2 3 4 5 files. When we open those 5 files, we will find that this script had included all the necessary library files from a variety of sources within Metasploit. Therefore, we do not need any additional include of this function library that was into it. After analyzing the metapreter.ruby file, this one, we find that it includes all those 5 files as seen in the picture. So these 5 files further includes all the required files from various places in Metasploit. So if you save this code into my script 1 directory and launch the script from Metapreter, this gives you a similar output like this. So we can clearly see how easy it was to create a Metapreter script and perform a variety of tasks and the task like automation as well. So I recommend you to examine all the included files within this 5 files that we discussed in our lecture. Railgun sounds like a gun set on rails. However, this is not the case. It is much more powerful than that. Railgun allows you to make calls to a Windows API without the need of you to compile your own DLL. It supports numerous Windows DLL files and is the way for us to perform system level tasks on the victim machine. So let's see how we can perform various tasks using Railgun and perform some advanced post exploitation with it. Railgun requires the IRB shell to be loaded into the Metapreter. So as you can see in here, we can jump to the IRB shell from Metapreter. We can see the preceding picture that simply typing in IRB from Metapreter drops us to the Ruby shell, Ruby interactive shell. We can perform a variety of tasks with the Ruby shell and then can execute any Linux command from here. Railgun gives us immense power to perform tasks that Metasploit cannot perform. We can raise exception to any DLL file from the bridge system and create some more advanced post exploitation mechanism. Now let's see how we can call a function using basic API calls Railgun and understand how it works. So this is the basic structure of a API call in Railgun. The client underscore Railgun keyword defines that you need the functionality of a Railgun for the client. The DLL name keyword specifies the name of the DLL file for making a call. The function keyword is the syntax specifies the actual API function that is to be provoked with requires parameter from the DLL file. So this is the example, and from this the result of this API will be like this. Here a call is made to the lock workstation function from the user 32 DLL that result in a locking the compromised system. As you can see, the system is in lock. So next let's see an API call with parameter. So this is the API. So when this command runs, it deletes a particular username from the client machine. So if you just try to delete the SSS username, as you can see in here, the user seems to have gone missing, or as you can see previously it was in here, but now it's not now. So Railgun is really an awesome tool, and it has removed the user's SSS successfully. Before proceeding further, let's get to know what the value nil is in the parameter was. The nil value from this here, the nil value defined that the user is in local network. However, if the system had been in remote one, we would have passed the system net -BIOS name in the parameter. DLL files are responsible for carrying out the majority of tasks. Therefore, it is important to understand which DLL file contains which method. Simple alert boxes are generated too by calling the appropriate method from the correct DLL file. It is very similar to the library file of Metasploit, which have various methods in them. So I recommend you to study a variety of API calls before proceeding further with creating a Railgun script. This will help you to get more information, and it will help you to work fluently. Taking a step further, let's delve deeper into writing script using Railgun for Metapreter extension. Let's first create a script which will add a custom name DLL file for the Metasploit context. So this is the script. So save this code under a file name urlmon.rb under the Metapreter directory. The preceding script adds a reference path to the urlmon.dll file that contains all the required functions for browsing a URL and other functions such as downloading a particular file. So we save this reference path under the name of urlmon. Next, we add a custom function to the DLL file using the DLL file's name as a first parameter and the name of the function that we are going to create as the second parameter, which is URL download to file A, this one, followed by the required parameter. The very first line of the code checks whether the DLL function is already present in the DLL file or not. So if it is already present, the script will skip adding the function again, and the pcaller, this one, parameter is set to null. If the calling function is not ActiveX component, and if it is set to the com object. So the SZ URL, this one, parameter specifies the URL to download. The SZ file name, this one, parameter specifies the file name of the downloaded object from the URL. So reserved is always set to null, and IPFNCV handles the status of the download. However, if the status is not required, this value should be set to null. So let's now create another script which will make use of this function. So we will create a post exploitation script that will permanently fix the specified wallpaper on the target system. So we will make sure that the registry to modify the setting of the wallpaper. So let's see how we can do this. So we created another script named directory in the same directory and name it as myscript.rb. As you can see, it is. So as stated previously, the first line of the script will call the custom added DLL function to URL download to file A from a urlmon DLL file that requires the parameter. Next, we create the directory under the policies. So so that the registry name called system. Then we created two registry value of the type, which is registry underscore SZ. Then what we do is we call them wallpaper and wallpaper style. As you can see, we call them at wallpaper and wallpaper style. So we assign the downloaded wallpaper to the value of the wallpaper registry key and wallpaper style to 2, which makes wallpaper stretch and fit to the entire skin. So let's run the script and the metadata to see how things actually work. So as soon as we run the my script, as you can see, run the URL mon and run the my script .rb, and the registry settings are modified on this target system. Moreover, this is the target system. So moreover, at the next logon, the user wallpaper will be changed and they are not be able to change it back again. So this was previously before what is on default, but after that it became this, as you can see in this screenshot, and they are not able to change it back again. So you can clearly see the power of Railgun, which uses the process of creating a path to whichever DLL file you want and allow you to download and add custom function to it as well. So in summary, throughout this lecture we saw how we can add custom function to the Metaxploit framework and use the Railgun on Ruby programming too. Also we learn about writing auxiliary modules and the basic of Ruby, and learn about the writing auxiliary modules. We saw how we can make use of the Railgun to add custom functions such as adding DLL file and a custom function to the target DLL file. So in this lecture, we're going to be talk about the pivoting or basic to advanced user case. So pivoting refers to accessing the restricted system from the attacker's system through the compromised system. Consider a scenario where the restricted web server is only available to like an user system. So in this case, we will need to compromise a user system. So let's give you an example of couple of the system and attacker. So let's give you first system name is Alice. So Alice system first, and then use it to connect to the restricted web server. And this means that we will need pivot on all of our requests to Alice's system to make a connection to the restricted web server. So this diagram, as you can see, makes it all clear. Considering the diagram, we have a 3 system and we have a Mallory who is an attacker, and Alice system and the restricted Charlie's web server. The restricted web server contains a directory named restrict, but it is only accessible to Alice's system, which has the IP address of .123, this one 192.168.75.130. However, when the attacker tries to make a connection to the restricted web server, the following error suggests like this. We will know that Alice, being an authoritative person, will have access to the web server. Therefore, we need to have some mechanism that can pass out requests to access the web server through Alice's system, and this required mechanism is called pivoting. Therefore, the first step is to break into Alice's system and gain metadata cell that access to the system. Next, we need to add a route to the web server. This will allow our request to reach the restricted web server through the Alice's system. So let's see how we can do that. So running the autoroute script. So this is the autoroute script with the parameter as the IP address as this one. This is the IP address, and restricted server using -s switch. that will allow, or that will add a route to the child list restricted web server. So Alice is the compromise system. However, we can do this manually as I can also do this manually as well, but manually adding a route to the operating system is kind of tricky, so we will just skip that. So next we need to set up a proxy server that will pass our request through the Metapreter session to the web server. So being Melody, which is the attacker, who need to launch a auxiliary module for passing request via a Metapreter to the target using SOX4. So SOX4, this is the target, and target is using this one. So in order to launch the SOX server, we have to set SRB host as this. This is the default SRB host, and the SRB port as 1080. So as you can show in here, so we just set all of those as default set to tor. So SOX4 as this is the web host, and this is the IP address, this is the port. So we are now all set to use the proxy in any tool. For example, Firefox, Chrome, and so on other browsers can use this tool as well. So let's configure the proxy setting in browser as follows. So as you can see, this will in default this will set as auto detect. So we are just gonna use this SOX. So make sure you use this as manual proxy configuration. So and what you have to do, you have to use this host as SOX host, and make sure you use SOX before, and make sure you use port 1080 as you can see. So after selecting this proxy, if you just go to that website that was previously restricted like this one, if you just go to now this website, as you can see, we have accessed the restricted area with ease, and we have an IP logger script that is running at the target web server in the directory called restrict. So this one, this is the directory. So what that will return? So if you just type ip.php, as you can see, your IP is this one. So again you can see there is a success. We are browsing the web browser with the IP of our compromise system 130. As you can see, 130, this is the compromise system. So as I was saying, we are browsing the web server with the IP of our compromise system, which is Alice system. Whatever we browse that goes through the compromise system, and the target web server thinks that it is Alice who is accessing the system. However, our IP address is 192.168.75.10, which is this one, but we are using our browsing as this one. So let's give you a summary. So we started by compromising the Alice's system. Then we add a route to the child list restricted web server from Alice's system through a Metapreter that installed in Alice's system. So we set up a SOX proxy server, which is this one, that automatically forward all the traffic through the Metapreter to Alice system. So we reconfigured the proxy chain with the address of our SOX server. So we configured that our browser to use SOX proxy with the address of our SOX server. So that's the total use case of pivoting. So in this lecture, we're going to be talking about scanning with Armitage. So we're going to talk about the basic of scanning the network. So Armitage has a separated tab named host to manage the host and scanning the host. So we can import host to Armitage via a file by clicking on import host from the host tab, or just we can manually add a host by clicking on the add host option from the host tab. Armitage also provides option to scan for host. So these scans are like two types, Nmap scan and MSF scan. So first, the MSF scan can make use of the various port and service scanning modules in Metasploit, whereas the Nmap scan make use the popular port scanning tools like Network Mapper, or the name that we know, which is Nmap. So let's scan the network by just selecting a intense scan option from the Nmap scan from the host tab. However, on clicking the intense scan, Armitage will display a pop-up that asks on the target range as you show in here. So make sure first you click on the Armitage and open the Armitage, then scan the network by selecting the intense scan option from the default page, and then just select the host tabs and then clicking the intense scan. Armitage will pop up this window. So as soon as we enter the target range, the Nmap will start scanning to the network to identify the ports, services and operating systems. So we can view scan details in this third panel of the interface, as you can see in here. So as you can see here, Nmap scan. This is the Nmap bar. So you can also check on the workspaces and console. So you can see in here Nmap scan on this port, as you can see, from 0 to 24. So it will scan all of those. So as you can see in this IP address, you have like 1000 ports, and discover the open ports are from TCP or from 902. So and also it completed the scene scan, and it all then initialized the service scan, and it completed the service scan which found one services. And as you can see in here, that initiating the OS detection. So initiating the OS detection in this specific address. So it will take some time, but after the scan has completed, every host on the target machine or host on the target network will be presented on the second panel, as you can see in here. Interface in the forms of icon that represent the operating system of the host, like this is the main operating system, this is the printer on this address, and this is the another machine that are connected. So these are all of those machines that are running on the target range. So how can you go to this? Just click on the workspaces, then you can see all of those, and you can also see all of those exploit payload, and you can use all of those options in here. So let's see what services are running on the target. So let's see what services are running on the host in the target range by just right clicking on the desired host and just clicking on the service. As you can see, a lot of service running on the first host, which is 128, this one. So just right click on this icon and just click services, and it will go to this page. So as you can see, so lots of services are running, such as Microsoft DS, SMB, Microsoft Windows, Apache server. On those ports also are running, like port 445, which is the running Windows XP. Then also on 80 there is Apache server is running, and this is the HTTP. So these ports can be easily fetched to catch as the host is running on the Windows XP box. So let's just target all of those services by instructing Armitage to find the matching exploit of this service. So we can find the matching exploit for a target by selecting a host on, then browsing those attack tabs and click just find the attack, and find attack will option will match those exploit database against those services that are running on the target host. As you can see, lots of services are running. However, after Armitage complete the matching of all services against the exploit database, it will generate a pop-up as you can see in here, similarly like this. And just after we click the OK, we will be able to see whenever we click a host that click on a host, and the new option that name attack is now available on the menu, and the sub menu will display all of those matching exploit modules that we can launch to target a host. So that's how we can just scan using a simple Armitage graphical interface. So you don't need to do any coding. It's just a simple graphical interface so that you can match or like model out the vulnerabilities and match all of those, and just take the analysis, and then you can just exploit with Armitage after that. So that's all about the scanning with Armitage. So previously we saw how we can like open Armitage, then like find out the vulnerability or machines, then modeling out the vulnerabilities, then we did find the match, then we like had a submenu that display the matching exploit module so that we can launch the target host. So in this lecture we're going to be launching exploit against a target using Armitage. So after the attack menu becomes available to a host, we are all set to exploit the target. So let's target the commonly exploited port, which is normally 445, which runs at Microsoft DS service. By browsing to the exploit from the attack menu, clicking on the exploit option will present a new pop-up that will display all the settings. So let's set all the requirement option as you can see in here as follows. So as you can see, we selected this machine to target, we selected our R host to this. So previously what we did to select those was in command using the command prompt. So in here you can just use the GUI interface or graphical user interface. So it's so simple and convenient. Other if you don't like to use the command terminal to use code, so it's better if you use this way. So after setting all the options, just click launch. So what we set L host to this, we set L port to this, and we set R host to this, and as I previously described, we set R port to 445. As you can see 445 in here. So target, you always target select to the automatic targeting, and make sure this is a must, you select the and tick use reverse connection, and you don't need to go to their advanced option because it's not necessary for you to give the advanced option setting. So make sure you select the user reverse connection, otherwise it won't work. So after all of this, just click on a launch to run the exploit module that against the target. So we will be able to see exploitation being carried out on the target in a third pane of the interface. As you can see, it will show this icon, as you can see reddish, and it will show some lightning. So it means that it's the launch the exploit module. As you can see, other one, this is the default, so it doesn't have the exploit modules, but it has, as you can see, this is the changing icon. So after we launch the exploit module, as you can see in here, we can see the metaparameter is launching, and which denote the successful exploitation of the target. So in addition, the icon of the target host changes to the reddish color that denotes the position of the host. So you can, so previously what it did is it set this as here, as you can see it automatically set all of those in command prompt because we use the GUI interface to set all of those. And as you can see, it set our host to this, it set the reverse TCP as an exploit or vulnerability. This is the, usually we always use this reverse TCP, and we set the SMB private browser, and we set target as 0. 0 means automatic targeting, and we just simply just exploit this. As you can see, it automatically detecting, and as you can see, selected target machine is Windows XP, and then it's running. As you can see, it messages metadata session is open from this IP address. So that's how you exploit with Armitage. So now in this lecture, we're going to be talking about post exploitation using Armitage. So Armitage makes post exploitation as easy as clicking on a button. In order to execute post exploitation module, right click on the exploitation host and choose the metaparameter 5 as follow. Just easy. Choosing metaparameter will present all the post exploitation module in sections. Suppose we want to elevate privilege or gain system level access. We will navigate to the access submenu. So we will go to this submenu and click on the appropriate button depending upon our requirements. But the interact submenu will provide option of getting the command prompt as another and metaparameter and so on. The Explorer submenu, which is this one, will provide options such as browse, file, show processes, log keystrokes, screenshot, webcam shot, and post module, which are used to launch the other post exploitation module and that are not present in the submenus. So as you can see in all of those, I already described what is this. So let's just run a simple post exploitation module by clicking a browse file, this one in here. So simply just click on the browse file. So after clicking on the browse file, this will show, so we can easily upload, download and view any files that we want on the target system by clicking on the appropriate button. This is the beauty of Armitage, which keeps command far away and present everything in a graphical interface, so that we don't need to do any command or any code that some people that don't like to use. That's why Armitage is very useful, because you can use it as simple as just couple of clicking the button, because it's all GUI interface and it's very simple. So this concludes remote exploitation attack with Armitage. So let's extend our approach to our client-based exploitation with Armitage. So attacking on the client side with Armitage. So client side attacking requires the victim to make move, as we have seen many times in our past lectures. We will attack the second host in the network that is running on a Windows 7 system. So in this attack, we will create a simple payload, send it to the victim, and wait for the victim to open our payload file just by setting up a listener on the incoming connections. So we are much more familiar with this attack, and we have conducted this many attack and many more returns in our previous lectures. by using the metaexploit or set tools and so on. So in this lecture now we will see the actual difference is there when we create a payload using a GUI rather than using a GUI or graphical user interface rather than using a command line. Therefore, let's see how we can create a payload and listen by performing couple of steps like search for a payload or browse for a hierarchy to find the payload that we want to use. So in this contents, in our current scenario, we will use the Metapreter reverse TCP. So we will use this TCP. So in order to use the selected payload, just double click on the payload. However, double clicking on the selected payload will display a pop-up that shows all the settings that a particular payload requires. So as you can see in this here, it will keep asking for your host, port, output and etc. So just complete the options such as lhost and lport, then choose the output format that are required, and then we have a Windows host as a victim in here. So we will select the exe, the executable file or the output format. This denotes an executable file. So after setting all the required option, click just launch to create a payload. However, this will launch another pop-up like this. So in this step, Armitage will ask us to save the generated payload. So we will type the destination file name in here and then just save the file. Now we need to set up a listener that will handle all the communication mode that made from the target host. After the exploitation that allow us to interact with the host. So in order to create a payload, navigate to the Armitage tab, select the listener, and this will generate a pop-up like this, and that will ask for the port number and the type for the listener. So we'll use port as 30,03004 and then type as Metapreter because we are using a reverse shell as Metapreter TCP. So just enter the port and type Metapreter, then just click start listener. Now send the file to the victim. As soon as the victim executed this file, we will get access to the system. This file looks similar to this. And an important point to note here is that while creating a listener, there will be no notification that the listener has restarted. However, it will automatically handle all the incoming requests and will change the system's icon as soon as the mark successful execution of the payload of the victim's end. So we can now perform all the post exploration feature at the target host by following exactly the same step that we did in our previous lectures. So let's see what files are available at the target host by selecting the Metapreter submenu and choosing the browser file from the Explorer submenu. So this will show up. Also, let's see which processes are running at the target host by selecting the Metapreter. As you can see, there are all of those processes are running like system, SMSS, WinNet, WinLogon service and etc. So we will target a host by selecting as Metapreter submenu and choosing a show process from the Explorer submenu. Then this will show up. As you can see, there are lots of executable file and PDF files in here. So, and that shows the process that are running on the target host. So this concludes our lecture on client-side exploiting. So that's how we use post-exploitation using Armitage and also attack the client side with Armitage. Hello everyone, so in this lecture we are going to be talking about agenda and payload technique. But first let's talk about exploit, because we are gonna talk about a lot of these using exploit. So exploit is a great tool for automated attacks and is being still developing day by day. Error found by user of these tools are fixed on a daily basis. However, for our attack, we will need to make a little modification to the script to carry it out perfectly. However, this is a one-time fix unless and until update is available to its patch. So let's fix the path issues. Path issues will affect the copying of files which are required by the attack vectors in order to set up our fake web pages. Thus, the issue can be fixed by performing a series of attacks such as open the fake update.python file under this directory using a text reader, then find the line with the os.system, this command using, and replace the proceeding of the line using this os.system command. Then payload generation, or like fixing payload generation error will result in a non-generational of a payload file for a Windows-based system. However, the files for Linux and Mac will still be generated to remove this error, and you have to perform something or couple of the steps like this, like open up this again, the fake update.python file under this directory, and you have to just replace payload and port under the name of the file of the Mac OS entry with the one that are on Windows OS. And then if the files available to this www directory under any Kali Linux or any Linux machine, it will be under the like modules folder, and that are not being copied to the var or wwd, which is the server of your Kali Linux machine or any Linux distributor. So what you have to do now is you have to just open up the terminal and manually copy those files from the www folder under the var folder by just issuing this command. Very simple command. This will move to this file under this var directory. Attacking a LAN with exploit. To attack a LAN with a fake update attack, open up the terminal and type the webexploit command to launch the webexploit. To perform the fake update attack, we need to issue the use network / fake update command that is shown in this picture to initialize this webexploit. Then the fake update attack will require you to set up two important variables, which is interface, as you can see, interface and host. So you can just set two variables, as you can see. I will also set it to interface as vmnet8 and host as this host. So we can set these two variables using the set command, as you can see in here. Just type set and just what you want to select, just type in here. However, to list all of those options and parameters to a module that recurs in a exploit, the show option command can be used, and after all of those options that a module will require are set, that we can run the module by typing just run. As you can see, just run program will just run all of those commands. So as soon as we can issue those run command, 4 external terminals will pop up, whether 3 terminals would be running different payload handles for Windows, Linux and Mac at a different ports respectively. The last terminal will display the status of DNS spoofing using ettercap. As you all know, auditor KPs, and we previously demonstrated the all of these uses of AtterCap. So after the attack executes, when a victim tries to open a website like any google.com, a pop-up will ask him to download a latest file like this or latest update file, as you can see in here, that will pop up and show the attacker, and the victim will need to accept the update file that will show, as you can show, and previously to execute it, because he or she will not be able to connect with any other website unless or until the attack stops. Also, so let's see what you have stored in our DNS spoofing terminal. From the proceeding screenshot, as you can see, we can see that the ettercap is redirecting so many site requests to the fake update server. Suppose our victim runs the update file. As soon as he or she runs the file, we get access to their system from one of the three payload handler depending on the operating system that is exploited. So as you can see, we got the access. So let's just stop the ARP poisoning and DNS spoofing by just press enter, and then it will go to this exploit terminal. So stopping then will lead to the normal browsing of the internet from the victim system, and he or she or they might think that the issue of the updating is now resolved. So clearly we force the victim to download the file in an attack, as downloading the file was their only last resort to resolve their issue with their internet. Therefore, this automated attack will consider handy while performing internal penetration testing. So in summary, so we check on the Metasploit features such as Websploit to fix up various broken functionalities in a Websploit to fast track into the set. So that's how you use payload to attack using ettercap to get the Websploit to get various information or update through Websploit in using the Kali Linux machine. Hello everyone, so in this lecture we're going to be talking about creating a payload using MSF Venom. So first let's talk about how we can use it. So we'll use it as a post exploitation on like a device, like for this testing purpose we will use a Apple iDevice. So Apple has been known for its secure device deployed in iDevices, which are iPhone, iPad and so on, iPad, Mac, all of those. So testing iDevices from the perspective of penetration tester is troublesome and it's very complex. However, if an iDevice is jailbroken, or some of us call jailbreak, the task became much easier to perform. So let's exploit iOS with Metasploit. So after we have seen how to exploit the SSH vulnerability from the previous lecture, so let's move on and log in to the SSH device of to this iDevice. So however, before we do that, let's try creating a malicious payload that will actually exploit the iOS. So let's just launch the MSF Venom in your Kali Linux machine. So make sure you use Kali Linux, because Kali Linux is the best for penetration testing attack. So Kali Linux, launch Kali Linux, open the terminal, just type MSF Venom and look for the generating and encoding the payload. Generally we use MSF Venom to produce malicious payload and encode the payload into a normal looking executable file. So in this case, we will use MSF Venom to create a malicious payload, that is this one osx.amal.shell.blind_tcp. So we will use the output files as macho, which is reported or represent the executable or a DLL file or a shared library file that are on the iOS operating system. So let's just try generating this file. So just type this one as I previously described. So after this, it will go to this directory. As you can see, there is no rhost. So the listening port is this one. So what we have to do now is we have to just show you the help or executable format as a previously shown DLL, exe or these formats. The -p switch denotes which payload to use. However, help and format will show us which format and the malicious payload can be created. So the -o switch will show the option which are required by the payload to be filled. So in the last part, in the this screenshot, we have used like -f switch to specify the format of the file that we will build. Moreover, we outputted the malicious payload into a name called iOS_this one bind_tcp. So the next step is to upload this file into a iDevice and make it run. So in addition, we need to ensure that the file is uploaded and it has a proper permission to execute. So however, let's see how we can upload the file in your iOS device. So as you can see, they will just list all of those vulnerabilities. So this is the vulnerability. Then after that, we logged into the device using the SFTP protocol. So we uploaded the malicious file onto the iOS device with ease. How we can do that? We just use the SFTP route onto this machine or IP address. So after that, we give our password. So after that, we put our iOS blind TCP in here. So what it will do is it will load to this exploit directory. So after that, as you can see, iOS bind TCP is running. So what you and working correctly. So now let's assign the required file permission. So as you can see, we gave the executable for all permission by specifying the a plus x, and we use the LDID utility to sign the file that we uploaded. So the LDID utility is basically a tool that stimulates the process of signing on the device or like iOS device, allowing us to install application that cannot be installed if the iOS device is not jailbroken. So in the last command, we executed the file in here, as you can see. So let's just quickly set up a handler for the payload that we have used, so it can accept all of those incoming connection made by the victim device. So we set up this handler. So just simply set payload as this one, so it will set up all of those. So we need to set up a handler with a matching payload. So we need to set the rhost. So we will set the rhost as this, and for this will exploit the work fully correctly. And as soon as we hit the exploit command, we get into a shell that target the device. As you can see, it will target this iOS device, and it is targeting all of those iOS device, and it will So what can we do? We'll just list all of those device by just simple ls command. As you can see, ls command. So we have the authority of this device and we can perform any further post exploration as we want. So example, such techniques can be enabled as an attacker to browse through the like WhatsApp history, delete contacts, recent calls, deleted pictures like Skype histories, and so on and so on. So that's how you use the MSF Venom to exploit iOS device using the Metaexploit framework. So far in the server-side attacks, we have seen how we can use a default password or use a misconfigured service to gain access to the target computer. Today we will be going through and have an example of a very simple thing, which is a vector. So some program or services are shipped or come with some embedded vectors on them. So we're going to exploit them, and I choose this very simple exploit because I want to introduce you to a framework called Metaexploit. So we're going to be using that framework a lot. So I wanted something simple to start with, then we're going to be go deeper with the framework. Now first let me show you how to find that exploit. So again, using the same method that we always been using, I have used nmap and I have to go for the 21 port. So we're going to using this framework, which is BSF FTP. So just search this, and as you can see, it has a Rapid7 website, and this is the exploit. So as you can see, the result comes, first result from the comes to the website called Rapid7. Now we have up to a Rapid7 company that makes this framework. So why I choose this particular exploit to show you today that. So we are going to exploit this service or this program or this problem using Metaexploit. As you can see, Rapid7 is telling that this is the version of FTP that has a backdoor command execution, so it will allow us to basically execute commands on the target computer. So if it has this program installed and unlocked, so we can use this program which is installed, and then you can execute commands on the target computer. So basically we want on the nmap, we google the name services, and first thing that came up the service which is the backdoor command execution, because this is, as you can see, first result Rapid7. So it will be using this command execution. So let's just copy this backdoor, which is this, and let's open our terminal and open MSF console. Okay, studying, so it will take up a couple of seconds. Okay, we are run. So just paste what you copy. As you can see, no use exploit, no payload is configured. So as you can see, we are now using this exploit. So just type show options to show all the options. As you can see, there is no rhost selected, only rport is selected, so we have to set our rhost. So the command you need to use to set rhost is just type set rhost, and type the IP address of our meta exploitable machine 192.168. Okay, I mistakenly entered, so let's type again. Set r host 192.168.1.101. so let's type again to show the options to see if our r host is selected or not. As you can see, our r host and also r port is now selected. So if we go to nmap, we can see that our port 21 is running on FTP. As you can see, FTP. So the client of our servers is running on our port 21. So this is, we don't need to change anything because we'll using port 21. So this is good. We need to change it to that. What we need to change is our r host that we changed. So just press enter after typing set r host and just you are just done. So what you have to do, just type exploit. As you can see, we are right now onto our meta exploitable machine. So we are right now on ID. So if I just type ID, as you can see, we are right now on our root access. If we just type ls, as you can see, these are all of the files that are on our meta exploitable machine, and we have access to our meta exploitable machine. And if we type pwd, as you can see, we are right now on root. So you can use any command that you can want in here in your target machine. So as you can see, this is very simple to use meta exploit, and in future we will be using more of our meta exploitable or MSF console, and we'll do the advanced stuff also.